Good morning, everyone. All right, all right. It's great to be back. It's great to be here for the Civil Conference after, a few years since we've done a physical conference, and to see so many people here and excited about the conference, it really is a great feeling. So thanks for being here, and we've got an incredible lineup over the next few days of learning materials. So I'm hoping you guys have a really great conference. First off, I want to thank our sponsors. Without them, it wouldn't have been possible maybe to put this conference together, so we appreciate their support. So do we have members of our sponsors here in the audience? If you do, I'll ask you to stand if you don't mind. Call you out just a little bit. But I want to thank Tobodot, 4M Analytics, and Burns & McDonnell for helping sponsor this conference and helping us pull it together. I also want to make a special call out to our Bentley Premier Scholars that are here. This is a new program that we've started over the past few years. We now have over 200 accredited Premier Scholars, particularly with Open Roads and Open Bridge, and we have a lot of them here today. So if you wouldn't mind, I would ask our Premier Scholars who wouldn't mind standing so people know who you are. So these groups of individuals have been working hard to put together an incredible data set for our digital delivery workshop. And so I want to give you just a little bit of a taste of that. So this is a data set that was built here in Denver, right? So we're here in Denver, and what better place to be for a civil infrastructure conference? This is a city that's booming, it's growing. And so what you'll see here is they reconstructed essentially aspects of I-25, the Bellevue the rail station, and then Union Avenue. But to look at the level of detail this model has. So they put a lot of time into this, a lot of work into it for this workshop. So again, my hat's off to the team for putting all this together. They didn't get compensated for this. They did this out of the love for the industry and the love for the technology and the love of being here. So another round of applause to our Premier Scholars. So my name is Dustin Parkman, and over the last 20 plus years, I've done nothing but work in this industry across design, build, operate, and maintenance. And I've never been more excited about where the industry is than right now. We're finally starting to see this convergence of not only the market conditions, but also the technology coming together, allowing us to kind of do the things that we've been talking about for, it seems like, over a decade, which is sharing information, integrating data, and being able to leverage the great work and artifacts that you guys do every day throughout the life cycle of infrastructure. So at Bentley, we refer to ourselves as the infrastructure engineering software company. It is all that we do. So there's no better place than we'd rather be than right here with all of you for the next few days. So when you think about civil infrastructure, we often think about it from terms of transportation, so roads and rail networks and a lot of linear stuff that we specialize in. But the reality is what you do spans all of these different industries, and these are all the different industries that we participate, particularly with civil infrastructure, across transportation, water, energy, mining, facilities, et cetera, et cetera. It all plays a vital role in what we do. And so for the past few years, we've been working on bringing these different systems together. So as we all know, there's lots of different engineering disciplines, there's lots of design disciplines, lots of different tools. It can be a bit overwhelming at times for the industry. So bringing this data together so that it can be leveraged, not just in the practitioner design process, but beyond that. And we refer to that as infrastructure intelligence. So these are just some of the data sources, the usual suspects that you would find in any given project or any type of infrastructure organization, whether it's subsurface data, geospatial information, the wide array of design and simulation software that comes about, systems that are in the field for SCADA and IoT, as well as all the wide range of survey artifacts and enterprise data. But it's really hard to pull all this together and make it be seamless and use the information across all these different stages. So our approach to this problem is what we refer to as an infrastructure digital twin. And so the simple way to think of that is just a virtual replica of a physical thing. A lot of the work that people in this room do, you're creating those virtual representations of what's going to be built, what's going to be operated, what's going to be maintained. And so by leveraging that as a visual index to find information is really, really an important part of where the industry is going. So many of you have probably seen a diagram like this before where it basically talks about the information loss that takes place over design, build, operate, and maintain. So there's these different stages where the data is handed over, it's lost, and then you have to rebuild it. So what we essentially are trying to do is compress that, right? We're not trying to solve it all, but we want to be able to compress that so that the right information can be carried from design to build, to operate and maintain. And for the people in this room, what I think is really kind of interesting is we're finally starting to see this convergence of where the artifacts and information that you are creating, particularly design and engineering data, can be leveraged more so throughout all of these different stages. Now, I think that's an interesting concept, not only to allow those other groups to use the information, but I think there's opportunities in commercial areas that you might be able to leverage to basically, that's your intellectual property, to be able to leverage that throughout the life cycle. It allows engineering firms and design agencies to create more value across the life cycle of infrastructure. So I'm going to walk you through a simple example of that. So from planning through design, through construction, and operation. So what do we mean by leveraging a digital twin in the planning stage? So at the beginning, it could be very much about understanding the site conditions, maybe even the site selection, if you will, if it was a new project. In this case here, I'm showing an existing airport facility, and we're just starting to look at, we're gonna enhance this airport. So we're trying to determine whether we're going to build a new airport, whether we're going to expand the existing airport. And so for the planners, this visual way of looking at the information is really powerful, not only to see kind of the model, but also to understand the utilities, the power, what's required, water conditions that are required, subsurface conditions, if you will, so that you can get a true 360 picture of what it is you're getting yourself into from a capital allocation perspective. And then once you've actually figured out what those options are, you can then explore that, either in conceptual design or preliminary design. So here we're showing just an example of where we're leveraging AI to kind of automate some of the sketching out of the conceptual design of a site. And so this gives you the ability to basically explore different options from a design perspective, but then be able to bring those design alternatives back into an environment where the stakeholders that have to make the decisions can actually interact with that information a lot more effectively. So here we're looking at some office buildings on the site. We've got some terminal information as well that's going to be built for this particular airport. And so the digital twin allows you to basically interrogate that information and look at those different conceptual options before you actually move into detailed design and before you move into construction. So once you've made your site selection, you've done your detailed design, then you want to be able to simulate the construction of that particular piece of infrastructure. So in this case, we have a facility that we're constructing where we've taken the design, we've broken it down into its constructible parts using a schedule and a 4D model. So basically taking the design model, breaking it down into its constructible parts, and then we simulate how it's going to be built. And this can be simulated at a conceptual level from a planning perspective, so you understand the risks and things of that nature, or it could be a very detailed scenario where you're actually planning out the actual construction itself with a detailed work plan, P7 schedule, et cetera, et cetera. And so this allows you to basically simulate the construction before it happens, understand your risks at a much greater depth, and be able to avoid construction liens and things like that. But once it's built, you want to be able to operate it and maintain it. Now, we're not saying that a digital twin is how you would operate and maintain infrastructure. There's a lot of systems already in place that do that. But it is a very effective way to visualize the operations as well as the engineered data that's behind it, all in one nice single pane of glass, if you will. And so leveraging the digital twin in this respect allows you to basically take all those data points that I was talking about earlier, put them into a visual index and interact with that information. So from a planning perspective, from a maintenance perspective, et cetera, et cetera. And then overall, across all of those different stages, the digital twin gives you this very rich visual environment for stakeholder engagement, for public engagement, anyone who has a skin in the game, if you will, for what's being built, they can interact with it in a very easy kind of game-like fashion. So if you look at this from a software architecture perspective, I'm not going to go into too much detail here, but essentially we assimilate all of this information, and behind all of this is our iTwin platform and our building infrastructure cloud. That is what allows us to assimilate this data and then provide these applications that allow you to search for information, to visualize information, to analyze and predict what's happening with infrastructure, and then interact with it in a lot of different ways, different modalities, whether it's the web, whether it's the desktop, whether it's mobile, whether it's virtual reality, et cetera, et cetera. And so we take that approach to basically leverage that across all of our key different product lines. So at the core, it's iTwin platform and our new Cesium platform, which is being converged together. That shows up in our Bentley Open Applications, as well as Bentley Infrastructure Cloud, and from an operations perspective, our asset analytics portfolio. So I'm just going to touch on a couple of key elements of things that we're doing in regards to making all of this possible. So one is a continued commitment to open standards. And these are just some of our key partners that we're working with on a number of different open standards. And I'll especially call out Cesium. Cesium was an acquisition that we made last year, right around this time. And that has really been a game changer for our geospatial environment. And so we're making that available throughout all of our products. So Cesium is essentially a geospatial 3D tiling system. It is best of breed, allowing you to really kind of deal with 3D geospatial information at city and national scale. So you have 3D tiles for geospatial data, including LiDAR, reality meshes, et cetera, et cetera. There's a wide range of different data sources, including Google's 3D tiles that we also pipe in. 3D tiles for BIM and CAD data, basically taking vector-based graphics and converting that into 3D tiles. And so here's a prime example. So John Holland, this is a project that took place in Brisbane, Australia. And so what they've done is they basically taken that platform, taken our iTwin platform and Cesium and built their own application. They essentially built their own digital twin system that allows them to take all of their design models, pull it all together, but then built a custom user interface on top of that to allow you to interact with that information. So here you can see you've got all of your BIM information for the highway, all the surrounding buildings, but you can simulate traffic, you can start to understand weather conditions, you can access different other pieces of information. And this has been a really powerful tool that they provided for their community so that the community in Brisbane can kind of understand the impact of the project itself. Another example is Balfour Bay Da Vinci. This is the HS2 project, or one of the HS2 projects in the UK. this rail project is a prime example, particularly for long and skinny projects where you have a rail network and spanning essentially an entire country. And this gives you an environment to interact with it in a very visual, effective way. And then a little closer to home, I'm going to show you what we're doing in MicroStation. So this same engine is now embedded directly in MicroStation as well as our DGN-based applications. And so here we're showcasing Cesium basically piping in 3D tiles directly from Google. You can bring that in to understand where your projects are going to take place. You can clip it, start getting terrain information, et cetera, before you go about your project environment. So I'd be remiss if I didn't talk a little bit about AI, and I'm not going to steal Barack's thunder, but we're doing a lot of different things in AI right now, and this is just a really practical example inside of MicroStation. So we've added a new scripting engine inside of MicroStation for Python, and so Python actually is dialed into large language models so that you can use it basically to help prompt and build out parametric scripts. So here we basically told it, hey, we want to build a parametric script to build a Jersey barrier. And we're going to build it based off of this line here. So basically we select the line, we can play it, but it basically, the AI wrote the script for it. But all we had to do was basically say, hey, we have this type of section. We want to reproduce those many sections around as long as this particular line is. And then if you move the line, it starts to react to it. Just a simple example of kind of leveraging AI pragmatically to do parametric modeling inside MicroStation, and these tools will be available in the other DGN applications. So without further ado, I'm going to hand it over to Barack to talk about what else we're doing with regards to AI.
Thank you, Dustin. Good morning. Well, it's an amazing crowd I see here. Thank you very much for being with us. My name is Burak Boyacı. I'm a bridge engineer by trade, and I've been with Bentley since 2017. Now I'm responsible for the products of like Open Roads, Open Rail, Open Bridge, and Open Tile. Today we're going to talk about how Bentley approaches to the AI and how it can help with the workforce shortage. Let's get started. Throughout the history, since the beginning of it, humankind looks for ways to make things more efficient, do more with less. In ancient times, Egyptians invented this machine called Herodotus machine to be able to lift these huge stone blocks to build pyramids, to save some muscle power. And then we invented the windmills and water pins for the same logic. We wanted to replace some muscle power. That was very much needed at that time. Later on in the modern ages, we invented textile machine. Textile machine did not only replace the muscle power, but also added serial production ability. And at the time, because of the booming of the population, that was very much needed, and to reduce the prices too. Later on in the times that's closer to our times, we invented the computers and robots. They did not only replace the muscle power, serial production ability, but also added quality and accuracy in the final products. Very much needed, right? So, considering all the challenges humankind is being faced today, what do you think is the next thing? Could it be AI? Before we get into the details of our industry, I wanted to show you something that I found very interesting. I personally thought that AI was always used for, or mainly used for technical stuff, creative stuff, analysis, simulations, and whatnot, right? I was wrong, apparently. Harvard Business Review says that in 2025, generative AI is being used the most for the emotional and personal support. Very interesting, right? You create something for a different purpose, and humankind finds the most needed thing and then use it. On the other hand, emotional and personal support has a big market share, right? So who doesn't need emotional and personal support? So I just want to share this with you quickly. So that said, AI is not the first revolution our industry is facing with, right? We did this many times in the last 4 or 5 decades. We started with the desktop and then moved to the cloud. Now almost everything is on the cloud right now. The way we convey the design intent has changed. We started with plans, just a piece of paper and line, no intelligence, no data in it. And then we moved to models and then databases because we realized that data is the most important deliverable for the downstream operations. Later on, we said, okay, we started with the CAD, and then we said, we can do better. What if we have a 3D representation of the asset and then assign data to it? And lately, we are switching to digital twins. And just to make sure we're on the same page, right? Digital twins are not equal to the BIM. Digital twins are live assets supported by IoT and sensor data. It does not only let you assess or evaluate the current condition of the structure or the asset, but also gives you insights to project what could happen in the future. What happens in 7.5 magnitude earthquake? What happens if you have a 100-year flood, right? Now, Dustin mentioned this a little bit actually, but I wanted to cover the industry challenges real quick to make my point. We all know that our infrastructure is getting older and we have to do something. We have to replace it. That means in terms of quantitatively, we have a lot of work. But not only quantitatively, but also qualitatively, design work is getting more and more complex. A lot of the design work is now in brownfield, not greenfield. We care more about the public safety and environmental effects. We cared less, honestly, about it a few decades ago. It adds another layer of complexity. Also, these complex projects require multidisciplinary workflows that you have to collaborate and work together. So all of what I've said so far indicating more work. Last bullet, workforce shortage, is saying that you need to do more with less. We saw a lot of retirements in the 5-6 years, and it's continuing. We are losing a lot of experienced engineers. But unfortunately, younger generation is not as interested in civil engineering as before. Some studies show that in the US, there are 10% less civil engineering graduates compared to last decades. And all civil engineering graduates are not doing civil engineering either, right? So now moving on to the industry trends. Industry trends are actually in line with the challenges. If you look at resiliency and sustainability, it means that you build something that lasts longer so that you don't have to redo it again. Automation, technology, AI, all to do with doing more with less. So now looking at the growing resource constraints, we talked with many of you, and actually you know this better than we do, that you all have more than 1 year backlog of your projects. In fact, this could be conservative. Some of you said 2 or 3 years. On the other hand, according to some studies in the UK, 1/3 of the employers cannot find the right skill set. Can you believe? 1/3. And according to another study in the US, there will be 400,000 construction jobs will remain open in 2025. There's a huge problem here that we need to find a way to tackle. So AI could be delayed. As you know, AI has been mainstream in different industries, like media and creative services, etc. When it comes to infrastructure and transportation engineering, let's be honest, we are a little bit conservative, right? We are, okay, let's see how it does, and then let me think about it if I'm going to do that or not. For good reasons, But there are a lot of studies that shows that AI could be a great fit and big potential for infrastructure projects. I can use some examples from the past. Because I'm a structural engineer, I'll give you an example from the structural engineering point of view, right? So in the past, before we invented the computers or computers becoming mainstreams, we didn't know much about the finite element modeling. A structural engineer had to solve a building or bridge or plant by hand. Can you imagine? Hundreds of pages, maybe even thousands of pages of hand calculations. Probably takes months. And then we invented computers. Computers became mainstream, and then we found more efficient ways like finite element modeling. And that months of work now is converted to a minute or hours, let's say. That's an amazing efficiency and productivity gain. But have you thought about how that engineer felt at that time? I'm giving some numbers to a black box and black box spits out some numbers. How do I trust that? I've been doing this in the 20 years with my hands. How do I trust this? But we did, right? This is not the only, AI is not the first revolution we have been going through. Similarly with the optimization algorithms and expert systems, we learn all the time trusting the technology to increase productivity. If you look at today, where we are with AI, we already do great stuff. We evaluate the site conditions. We can detect cracks with photogrammetry or faults or the condition of the bridge with AI algorithms. We can place a camera on the dashboard of a truck, and then we can identify the highway inventory and find the defects. Also, we said there are a lot of projects in brownfield today. It's a very difficult job to go back to all the historical specs and documents and then evaluate what has been done, what was the intent in the original project for a maybe 100-year-old highway or bridge, right? So AI can summarize those insights for you within minutes. Now, the most exciting part, generative design. We already started to automate a lot of repetitive and mundane tasks with generative AI, writing specs, drawing production, etc. And also, not only that, but also AI can train an entry-level engineer, not only for the engineering perspective, but also how to use a software the best. We've said that AI is at an inflection point, and we are hopeful that it's going to find some solutions to the biggest challenges that humankind is having today, such as climate change or health-related stuff. And we believe that AI for infrastructure is not an exception for this. On the other hand, we realize and acknowledge that there are risks and concerns. For example, some of our users are telling us that I don't know how my data is going to be used. I don't know if I'm going to be losing the control of my data. I don't know if I provide my data, am I going to lose my competitive advantage to others? Very valid concerns, and we'll get into those. First of all, generative AI for infrastructure, we approach it from three perspectives. We think in Bentley that you can certainly get started with much better design alternatives very early on in the project. And then, seeing this very early on the project, it can lead to a more resilient and sustainable option from the beginning. It can also provide you better forecasts for cost or project overrun. And then you can reduce the risk accordingly. Also, it can automate deliverables, drone production, plan creation, and it can do it in a standard way with a higher quality as long as you teach it how to do it, right? And then it gives you more time to focus on more challenging things. So to sum up our views, Bentley thinks that with AI in infrastructure, it can boost efficiency and productivity a lot. Considering all the workforce shortage, considering all the huge backlog on the way, why can't we assign AI for the repetitive and mundane tasks that you really don't want to do? It's boring stuff, right? Instead, you more focus on the challenging design problems where you need to use your engineering judgment. Also, connection is a key thing here. Bentley has a unique advantage overall because we have iTwin platform. As we said, these complex projects require multidisciplinary workflows. And iTwin platform is providing an open space, open platform for all those multidisciplinary people to collaborate on. And looking at the whole picture, it's a great place to train AI algorithms. On the other hand, context is crucial when you're training AI algorithms. I'm sure a lot of you are using LLMs today, different products, right? How many times you ask a question and you got a weird answer or made up answer? Why is that? Because that algorithm is not trained on the context that you're asking the question on. The advantage of Bentley is we are specialized and domain expertise on every assets of the infrastructure that we can train on that domain specific expertise. Like we can train an AI algorithm for bridge design, for highway design, for plant design, you name it. And then we can eliminate this AI hallucinations. Last but not least, we certainly think that AI is not going to replace engineers. It will augment and assist. As Jensen, CEO of NVIDIA, says, you are not going to lose your job because of AI, but you may lose it if you don't take advantage of AI because somebody else will eventually. Now, going back to the data privacy concerns. So we have 3 principles in Bentley: control, contribute, and trust. First of all, your data is your data, period. You are going to let us use your data or not, completely up to you. And if you let us use your data, you will decide how it will be used. Is it going to be my personal design only? Is it going to be for my organization only? Or is it going to be contributing to the entire engineering community? And then we will be completely transparent on how we are using your data so that there won't be any questions. Now, let's take a look at the specific examples of how Bentley utilizes AI today. Let's start from the operational side of the life cycle. As you know, DOTs, owner-operators, they have to manage thousands of miles of highways and probably tens of thousands of assets on those highways or railways. Bentley Asset Analytics is playing a crucial role deploying AI technology on making sure those assets remain safe, reliable, and resilient. Here's one example. Roadway networks are complex and there are many assets on them. In order for an owner-operator to manage those assets efficiently, they need to create the inventory list first, complete and comprehensive. And that's very difficult. With Linksy, utilizing crowdsourced data with the cameras placed on the dashboards of the trucks or other vehicles, it can easily detect all the assets in a highway and then create inventory very quickly. So that's the first step. The second step is using AI algorithms. It can actually find the defects. Could be broken guardrail, could be a malfunctioning traffic signal, you name it. By doing so, we believe that inspection time is going to be reduced by 90%. Therefore, owner-operators are not going to spend their valuable time on finding the issues, deploying crew on the ground. They can spend their time on fixing these issues. Similarly, bridge inspections are crucial for the public safety. We have had some unfortunate events recently. Bridge inspections can happen every 2 years for certain bridges, or 1 year or 6 months, depending on the condition of the bridge and criticality of it, right? But bridge inspections are dangerous. Dangerous for the inspectors and dangerous for the public safety. Bridge inspections are very expensive, and they are not always very accurate because you can't get closer to where you want to be, and then you have to ballpark certain measurements. With I2N experience, using photogrammetry techniques and machine learning algorithms, you can actually detect all these deficiencies. Could be cracks, could be potholes, could be spalls, rusted, exposed rebar, and then you can still deploy a crew to the field, but not to do the inspection of the whole bridge. You can pinpoint, go to that girder 2 feet away from the abutment and check that spot if needed. Now, switching to the design side of the life cycle, OpenSite Plus is the first I2N native design applications that Bentley created. We talked to many site designers, site design firms. It's not an exception in terms of workforce shortage, right? They are not able to find skillful site design engineers, but the work keeps coming. Either their backlog is keep increasing, or they have to reject work. Therefore, we've created OpenSite Plus to utilize Copilot Design Assistant, site layout optimization, and automated drawing production to increase this efficiency and productivity of the site designer. Therefore, they don't have to keep growing the backlog. Let's take a look at one example here. We are going to build a hotel next to a new airport. In OpenSite Plus I2N native application, you can get the project started very quickly and pull in the relevant information for terrain, let's say, or parcel information, or CAD data for roadway design from multiple resources, maybe Cesium 3D tiles, Google Maps, Azure connection, right? So you can get the project started very quickly. And then the next step is to getting the design started. So in OpenSite Plus, we utilize AI Copilot Design Assistant. What it does is you can upload a document, could be a design spec, could be zoning requirement document, and then once you upload it, you can query and ask questions. In this case, we're asking, can I actually build a hotel in this zone? It finds the answer, says yes, and then gives a reference for you to go back and check if the reference is correct. So good, we can design it. Now we're adding some smart objects like roadway and parking lot. Now, what I can do with Copilot, I can cross-check the model against the requirement documentation that I send. I can ask a question, number of parking spaces I modeled here, is it compliant with the document that I uploaded? It says yes. All right, we're good. Now the next step is, because we just placed the hotel somewhere and parking lot somewhere else, right? I can ask Copilot that, can you optimize my site layout? Give me the best options. It comes back with multiple alternatives with a different dollar amounts attached to it. So you pick one, model gets updated accordingly, and then you move on. You can also modify your model with the NATO language. You can ask Copilot to change the depth and the length of a parking space and its orientation. And boom, it does it for you. So just to summarize what Copilot can do today, one, it can check design requirements for you. Number two, it can check design requirements against the model you created and say if you are compliant or not. Number three, it can optimize the design layout you started with and give you options. Number 4, you can actually use your native language to modify math. Now, drive automation. Again, we interviewed many site design firms and site engineers. They all told us that they spend more than 50% of their time for drone production. More than 50% of the time. That's why we created this AI-powered drone automation tool. So you can easily cut sheets and create sheets, but also AI agent can place the labels and annotations automatically in the most aesthetical possible way. Because it learned from hundreds or thousands of plan sheets that was provided before, so it knows where to place what. So we've been talking about OpenSite Plus, this exciting stuff all the time. You probably are wondering, when am I going to see this in the mainstream products? OpenRose, OpenRail, OpenBridge. I can tell you that we're working on very hard on getting these down on the mainstream products too. In fact, you will see some of it very soon. But I don't want to steal the show because the team is going to get into details later on in the upcoming sessions and give some good news. By the way, I should include MicroStation into this as well, not only Silk products. My last announcement is about our major release timeline. As you know, we've been releasing in Q3, Q4 timeframe, typically. Starting 2026, we are changing this. MicroStation is going to release in Q1, and civil products are going to follow early Q2, so that we are pulling ahead a little bit in the calendar year. That's it. Thank you very much for listening to me.